Our topic for today is about percentage yield. At the end of this video, you will be able to calculate the percentage yield of a product, solve applications related to the percentage yield. In a chemical reaction, usually the experimental obtained quantity of a product is always less than that calculated using stoichiometric ratios. This difference is due to many factors. Number 1. Maybe it's due to the formation of side products other than those represented by the equation of the reaction, or maybe due to the loss of a portion of the reactants and the products during the experimental setup of the reaction. So maybe during the filtration process, in order to filtrate the obtained product, a small amount of the product will stuck on the filter paper and will be lost. And finally, it's maybe due to the presence of some impurities in the reactants. So how to calculate the percentage yield? The percentage yield of a reaction is the ratio of the actual mass of the obtained product, which is the experimental quantity, divided by the theoretical mass multiplied by 100. So this ratio may be depending on the mass, or maybe depending on the number of mole. So for the actual yield, usually it will be given for you, while for the theoretical yield, it must be calculated from stoichiometry. But here, if you have the percentage yield and you have the theoretical yield, we can deduce the actual yield. So let's solve this application together. 2.4 gram of magnesium reacts with a certain amount of oxygen gas to give 3 gram of magnesium oxide. Here the two reactants are in stoichiometric ratios, given also the molar masses in a gram per mole for magnesium 24 and for oxygen 16. Write the balanced equation of the reaction. So you have just to add the proper coefficients here. Indicate the type of the reaction. It's a combination reaction where two reactants combine to give only one product. The most important question here, calculate the percentage yield of the above reaction. So the percentage yield for the only product here, magnesium oxide, it's equal to the actual mass of magnesium oxide divided by the theoretical mass of magnesium oxide times 100. So looking at the given here, you have the actual mass of magnesium oxide, which is equal to 3 grams. So the given value here represent the actual mass of magnesium oxide, or the experimental obtained mass. So in order to calculate the percentage yield, I need first to calculate the theoretical mass. So the theoretical mass is calculated using stoichiometric ratio. Now, in order to use the stoichiometric ratio, we need to calculate the initial number of moles for magnesium first. So the number of mole for magnesium is equal to the given mass for magnesium 2.4 gram divided by its molar mass 24, so it's equal to 0.1 mole. So here, starting with 0.1 mole of magnesium, we can say now, according to stoichiometric ratio of the reaction, the reacted number of mole for magnesium divided by its coefficient 2, it is equal to the reacted number of mole for oxygen divided by its coefficient, which is 1, which is equal in return to the formed number of mole for magnesium oxide divided by its coefficient, which is equal to 2 here. So in this case, since both reactants are consumed totally, we have here a stoichiometric mixture. The number of mole for magnesium reacted over 2, it is equal to the formed number of mole for magnesium oxide over 2. So here you can depend on the first ratio, or the first reactant, magnesium, in order to calculate the formed number of mole for magnesium oxide, or you can depend on the second reactant, oxygen gas. So you can take the second ratio with the formed number of mole for magnesium oxide. So here I'm gonna take the following. We can say that the number of mole for magnesium over 2, which is reacted, it is equal to the formed number of mole for magnesium oxide over 2. So you will get that the reacted number of mole for magnesium, that is equal to the formed number of mole for magnesium oxide, which is equal to the initial value, since the amount of magnesium initially present reacted completely during this chemical reaction. So it's equal to 0.1 here. Now I need to calculate the mass of magnesium oxide. So number of mole, it's equal to mass over molar mass. So the mass of magnesium oxide, which is formed at the end of the reaction, it is equal to 0.1 mole times 40, which is the molar mass of magnesium oxide that can be calculated. So we can say now that the theoretical mass of magnesium oxide, it's equal to 4 grams. Now, as you notice here, the actual mass of magnesium oxide, which is equal to 3 grams, it is less than the theoretical mass, which is equal to 4 grams, and calculated now. So, to calculate the percentage yield of magnesium oxide, it is equal to the actual mass divided by the theoretical mass times 100. So here we have 3 grams over 4 grams times 100. So it's equal to 75%. So the percentage yield of magnesium oxide is 75%. Let's solve another application. 80 grams of calcium reacts with 0.2 mole of oxygen gas to give 9 grams of calcium oxide. Given the molar masses in gram per mole for oxygen 16, for calcium 40. Write the balanced equation of the reaction. Specify whether the initial mixture is stoichiometric or not. So here you have to calculate the initial number of mole for calcium first, which is equal to mass over its molar mass. So we have here 80 grams divided by 40 grams per mole. So the initial number of mole for calcium will be equal to 0.2 mole. Now we have to calculate the two ratios for the two reactants for calcium and oxygen. The ratio for calcium is equal to the initial number of mole for calcium divided by its coefficient. Here it's 2. So we have 0.2 divided by 2, it's equal to 0.1 with no unit. The ratio for oxygen gas is the same, it's equal to the initial number of mole, which is given for U. It's equal to 0.2 mole over its coefficient, which is 1. So the ratio for oxygen gas, it's equal to 0.2. So here, by comparing the two ratios, since the two ratios, they are not equal, so the mixture is a non-stoichiometric mixture. Identify the limiting reagent. Since the ratio for calcium is equal to 0.1, is less than the ratio for oxygen gas, which is equal to 0.2. So here calcium is the limiting reagent, while O2 is in excess. Calculate the percentage yield of the above reaction. To calculate the percentage yield of calcium oxide, the only product here, it's equal to the actual mass of calcium oxide divided by its theoretical mass times 100. The actual mass is given for U and it's equal to 9 grams. So this is the actual mass or the experimental mass. Now, before calculating the percentage yield, I need to calculate the theoretical mass, and it will be calculated using the stoichiometric ratio. So, according to the stoichiometric ratio of the reaction, since Ca is the limiting reagent, so we can only depend on the limiting reagent in order to find the formed number of moles for calcium oxide. So here we can say that the number of mole for calcium which is reacted completely during this chemical reaction over its coefficient 2, it is equal to the formed number of mole for calcium oxide over 2. So we got that the reacted number of mole for calcium, it's equal to the formed number of mole for calcium oxide, and it will be equal to 0.2 mole. So here, for the limiting reagent, the reacted number of moles for calcium, since it is the limiting reagent, it is equal to the initial number of moles for calcium, and it's equal to 0.2 mole. Now, I need to calculate the mass, the theoretical mass of calcium oxide. So here we have number of mole, it's equal to mass over molar mass. You can calculate the molar mass and it will be equal to 56 grams per mole. Now we can say that the mass of calcium oxide formed is equal to the number of mole times the molar mass. So it will be equal to 11.2 grams. So this is the theoretical mass of calcium oxide. That it's calculated using the stoichiometric ratio. Now for the percentage yield of calcium oxide, it is equal to the actual mass, which is equal to 9 gram, divided by the theoretical mass calculated now, 11.2 gram, times 100, and it will be equal to 80.3%. Thanks for watching. See you next time.